Good morning, students. This is Shahniaz sir. Hoping you all fine. Last class, we have learned the topic security protocol. This is a question that you have done. Today, we start with a new topic that is encryption. We learned symmetric encryption. The question that you have to do after the class, that you have to write in your copy, define the term encryption, state the types of encryption, define all the encryption terms, define symmetric encryption, and the process of symmetric encryption. So now, take your computer, textbook, and classwork copy. Go to page number 104 of your textbook. Here you are, encryption. Encryption is used primarily to protect data in case it has been hacked. Why is encryption won't prevent hacking? It makes the data meaningless unless the recipient has the necessary decryption tools described below. Encryption is a term. It won't prevent hacking, but it makes the data meaningless. Means when you apply the technique encryption, the data becomes unreadable. The data becomes unreadable, and you use encryption by applying some of the tools, by techniques, by algorithm. So whatever techniques you apply to make the data unreadable, the same techniques needs to make the data readable again. So the recipient needs to apply the same method to get the data, to make the data unreadable and reads the data. So even in the middle, if hacker hacks the information, he cannot understand because the data is meaningless for him. So now there is question types of encryption. There are two types of encryption, that is symmetric and asymmetric or public key. Now we'll go with the symmetric encryption. Symmetric encryption is a secret key which can be a combination of characters. If this key is applied to a message, its content is changed, which makes it unreadable unless the recipient also has the decryption key. One key is needed to encrypt a message and another key is needed to decrypt the message. It is obviously important that the sender and receiver have the same encryption and decryption key. Yes. Symmetric encryption is some combination of key is applied to make the message unreadable, and that is a secret key, and the same key is needed to make the message readable again. There is clearly a security risk here, since the sender has to supply the key to the recipient. Yes, because the same key is needed. The same key is used to make the message unreadable and readable again. So you have to share the key with the recipient. This key could be intercepted by, for example, a hacker, which puts the security of the encrypted message at risk. Yes, when you are sharing the key with your recipient, by this time the hacker can hack the key and your message get into a risk. This situation is referred to as a key distribution problem. So we have a problem here that is called key distribution problem. When you're trying to sharing your secret key with the recipient, then you have to get this problem. You'll face this problem, that distribution problem. So the question is, how can both sender and receiver have the required key without sending it electronically in some way? The following routine shows how this is done. There's a technique we apply. We don't need to send a key, we generate the key, follow it through, and you will see that the both sender and receiver end up with a key which is effectively secret, but didn't involve sending the actual key electronically. We're not sending, we're actually generating the key. So here we are. So now these are the 4 stages that you have to do. The sender and the receiver, they have to do these processes to generate the key. The sender uses an encryption algorithm. They are using an encryption algorithm and choose a value. Easy, mane x equals to 2. This keeps secret. So they have the sender choose the value 2, and it keeps it secret. The receiver uses the same algorithm and also choose the value y equals to 4, and also it keeps secret. This value of x is put into a simple algorithm, that is 7. The 7 is a default value used here, and the value of x is 2, so you put the power 2 you'll give here, and it will mode 11 is a function. Mode is a function that gets the remainder. You when you wants to get the only the remainder from any math, so you use mode function. So here you will get a remainder. So mode gives a remainder when dividing the number by 11. So you have to divide the number, the whatever the number is produced here, by 11. So 7 square is 49, mode 11. So 49 mode 11, which gives the value that is 11 4 to 44, and we have the remainder 5. So we have generated the number that is our remainder is 5. Same way, the recipient also use 7 as a default value, and the power the 4 is secret value, so it's given 4 as a power. So 7 to the power 4 mode 11. So that is answer is 2401 mode 11. So the it's 218 times, and the remainder is 3. So here in this case, in the recipient's remainder is 3. The sender recipient key is that remainder is 5, and recipient's remainder is 3. Now the sender now sends the value just calculated, the 5 to the recipient. The recipient also sending the value just calculated to the sender. Now this new value is put into the same algorithm. The new value replaces 7. You remember that 7 used for the calculation. So we are changing that the value 7 with the recipient's, or in this case, in the sender case, the recipient's value, and the recipient's case, sender's value. So we are having 3 here, 3. So 3 is replace the 7. So now we are having 3 3 is 9 mode 11. So it's index is 0, and the remainder is 9. In this case, the sender's value was 5, so it's using 5. So 5 to the power is 4 is 625, and divided by 11, so the 56, and the remainder is 9. You see, in both cases we get the same number, that is 9. So here they are telling, thus both sender and recipient end up with the same encryption and decryption key of 9. This gives us the basis of how an encryption key can be generated. So this is the way you can generate the encryption key. Now use the following sender receiver value to check that system describing table works correctly. So you use this one. This is your SW. You do it at your home and find out the same encryption key is produced or not. Now table 8.1 refers to an encryption algorithm. As you will see in section 8.7.3, messages are put through an encryption algorithm to produce a message in encrypted form. This algorithm uses an encryption key to produce a message which appears meaningless unless the same key is applied to unlock. The original message, the key is referred to as an encryption key or a decryption key, depending whether it is used to encrypt the message or to decrypt the message. The next section discusses another type of encryption. So today's class we are only learning symmetric encryption now. From the book, just learn this this process, and learn this these notes, and do go through the process. I will give you another note which solves the other question. Here there's a question, what is encryption. So for that question, uh, for that question encryption, you write the definition: the process of changing the plain text into ciphertext. Only this line you have to write for the definition of encryption. There are two main types that already have explained from your textbook. So these are the type. Now there's another question: what is define all the encryption terms. So these are all the encryption terms. So I'm reading one by one. Following are some of the some important terms related to encryption. Before continuing, you should know what these terms are. These terms are not given in your book, so we have to learn these terms from this note. Plain text, the information in its original form. This is also known as clear text. Actually, the real information, that is whatever you type, whatever you have to send, when it is in normal form, it's called plain text or it is clear text. So anyone, this message is clear and plain, so anyone can understand this message. Now ciphertext, the information after it has been obfuscated by the encryption algorithm. When you have encrypted the message, after encrypting your message, the new message, what is unreadable form, that unreadable form is called ciphertext. Now encryption, that just we have learned encryption, the process of changing the plain text into ciphertext. Decryption, the process of changing the ciphertext into plain text. Your in the encryption is the process of changing the plain text, the normal text into ciphertext, and this one is a reverse form. The whatever the ciphertext, it makes back into the plain text. Now encryption algorithm. An algorithm defines how data is transformed when original plain text data is scrambled to ciphertext. Okay, these are algorithm used for encrypting the message. These are some other extra notes. Just for the definition, you write up to this. These are the other extra points. Just learn, but no need to write. Both the data sender and recipient must know the algorithm used for data transformation. The recipient should use the same algorithm to decrypt the ciphertext back into the original plaintext data. Now, encryption key, a key is secret value which is used as an input to the algorithm along with the plaintext data when plaintext is converted to ciphertext. The encryption key is applied when you are encrypting the message. The same secret key should be used to decrypt the ciphertext back into the plaintext data. Now, cryptography, the art of concealing information using encryption. This is the art of concealing information, or concealing is hiding information. So cryptographer, an individual who practices cryptography. Cryptanalysis, the art of analyzing cryptographic algorithm for identifying the weaknesses. Cryptanalyst, an individual who uses cryptanalysis to identify the weaknesses in cryptographic algorithms. So these are the terms that you have to learn before going for the encryption topic. Now the symmetric encryption, the definition of the symmetric encryption, you learn write from here and learn from here. Type of encryption where the same key is used to encrypt and decrypt the message. With symmetric encryption, cryptography, both the sender and recipient share a key that is used to perform both encryption and decryption. This is for the definition only, up to this you have to write. Okay. Symmetric cryptography is commonly used to perform encryption. It also provides data integrity when symmetric keys are used in conjunction with other algorithms to create messages, authentication codes, MACs. You don't need, just learn, just read one time. No need. Here is the image, of symmetric symmetric encryption. The process of encryption and decryption the shared secret key. Here we are using only one, that is shared secret key. The same key is used for encryption and decryption. First of all, sender make a plain text message, the normal message in clear text. Everyone can read the information. So applying the shared secret key, and encrypt the message. That message becomes ciphertext. The plain text becomes ciphertext, and it sends the message to the recipient. The recipient when receive the message, it decrypt the message. Decrypt the message using the same shared secret key. Make the ciphertext back into plain text and gets the information. So the process here the three process that you have to write. The process of symmetric encryption. So symmetric encryption involves the following steps. The sender creates a ciphertext message by encrypting the plain text message with a symmetric encryption algorithm and a shared key. The sender sends the ciphertext message to the recipient. The recipient decrypts the ciphertext message back into plain text with a shared key. So these are process that you have understood. What happened. Now I will show you a video. You can you better understand. So here we are. Now look at the video. We have the plain text input is here. So secret key shared by send and recipient, symmetric encryption, transmitted ciphertext, whatever the message you have, that message is transmitted. and secret key shared by same, and this is the same key are used here. Decryption algorithm, reverse of encryption algorithm, and it gets the message. The message is different here. This is the ciphertext and this is the plain text. The plain text output. So plain text input uses uses keys. The same keys used here to encrypt the message, transmitted the ciphertext, and the receiving end the same, and the ciphertext using same secret key decrypt the message and gets the plain text output. So guys, understand, you understood the message, the process of symmetric encryption. The same key is used here to encrypt and decrypt the message. So thank you very much, guys. Uh, Goodbye.